Hello and welcome to our webinar series, Succeeding with Forecast Pro. Today, we'll be discussing project hierarchies. Hello, my name is Franklin Rea and I'm a senior trainer with Forecast Pro. I'll be hosting this webinar today. This webinar series, Succeeding with Forecast Pro, is run once every quarter and it's free to sign up, so we encourage you to sign up for these sessions when they come out. Our next webinar will be in February and will cover overrides and collaboration. All of our webinars are recorded, so after today's webinar, we'll send you a link to the video. Also, all of the previous webinars that we've run in this series are available on our YouTube page, which my colleague James will put a link to in the chat. In addition to this webinar series, we also have a second webinar series that covers general forecasting topics, and this is also run once every quarter. You can sign up for that webinar series via our website as well. Beyond the webinars, we also run live forecasting seminars that are multi-day deep dives into forecasting techniques. You can sign up for these on our website, and if you'd like to learn more about Forecast Pro beyond these public sessions, we do offer custom Forecast Pro training. My colleague James and I work with clients from around the world, helping them set up their Forecast Pro projects using their own data and designing custom training to meet their needs. One final bit of housekeeping for this webinar. At the end, we're going to take Q&A, so please, throughout the session, as questions come into your mind, put them in the chat. James will be monitoring the chat throughout, so we'll gather all the questions at the end, but please don't hesitate to ask the questions as they come to you. In terms of an agenda for today's webinar, we're going to start by going over an overview of how hierarchies are used in Forecast Pro projects. We'll then look at a few examples using Forecast Pro software to explore these ideas. And finally, we'll wrap up with some conclusions and closing remarks. Then, as I mentioned, we'll get into your questions. So again, I really hope you enjoy this webinar. Let's get started. So what are we going to cover in today's webinar? Today, we're really going to look deeply at creating a hierarchy for your project and what a good hierarchy allows us to do. So why does every Forecast Pro project need a hierarchy? And what are some of the typical categories or groups that we would expect to see in a hierarchy? There are really four main reasons, and we'll do examples that sort of line up with these. First and foremost, a hierarchy is a primary key for your project. It determines what levels we can forecast at, what levels we can report on, and how the data aggregates up and down. Sometimes we see individual product codes or SKUs down at the very bottom of a hierarchy. Sometimes we see them higher up. It all depends on the needs of your project. This brings us to our second point, which is that the structure of the hierarchy is a factor in how the models are generated. The number of levels determines how much we split the data before we get to the most granular level. And we have choice as to where the models are built and whether they're rolled up or disaggregated down. Thirdly, the hierarchy is where you're going to enter adjustments or overrides. As we'll see, we can do this at the end item level, group level, or even all the way up at the top. And these choices aren't mutually exclusive, so we can make adjustments anywhere in our hierarchy. And lastly, we need these groupings to successfully create reporting and output files. When setting up a hierarchy, you want to think what categories are meaningful for driving your business, that we would want to report on, that we need forecasts for, and what order they should go in. So what are some categories that typically go into a hierarchy? Some of the more common ones are geography, customer, product line, distribution center, and SKU or item code. However, how you structure your hierarchy is up to you. It's also important to note that the number of levels in your hierarchy is your choice, although we typically see that anywhere between 2 and 8 tends to be ideal. And based on the categories that you choose to put in your hierarchy, you can have them in any order. So for an easy example, here we have part of a hierarchy that starts with product line and then has at least one customer below that, probably many others, and then we're looking at the SKUs sold through that customer. But we could just as easily have gone the other way. We could have rebuilt this hierarchy to start with product line, and then the SKUs that we're selling, and then for each SKU, which customers we sell it to. And it's somewhat important at the outset to consider for your data and your reporting purposes which will be better, up to and including simulating multiple projects and forecasts in different hierarchies to understand which hierarchy levels and order are going to be best for you. With that said, let's start looking at our examples. So today we're going to go over 4 examples of how you can build on your hierarchy to get the best forecasting experience from your project. In our first example, we'll look at how filters are used to slice and dice your hierarchy along dimensions that need not be in the hierarchy itself. Then we'll examine the options for building statistical models at different levels of your hierarchy and look at why going top down or bottom up might be preferable depending on your data. Next, we'll see how entering overrides at different levels of the hierarchy impacts the final forecast. And finally, we'll create some reports using the group levels we built into the hierarchy as a guide. So in our first example, I mentioned that some data attributes don't belong in the hierarchy, but we still need to report on them anyway. What do we mean by this? Well, the example I typically like to go with is sales rep. I'd probably never include a level in my hierarchy that involved a specific sales rep by name. Consider what happens if that person quits at the drop of a hat, or more mundanely, gets assigned to other products, or hires a subordinate to take on some of their territories. All of these possibilities would result in a shift in my hierarchy, either involving renaming, reshuffling, or recategorizing my items, which could not only lead to general confusion and messy data from month to month, but also sever continuity between historic forecasts and future planning. And another thing to consider is the total complexity of my hierarchy. If we just keep adding levels for every attribute of my data, then as we walk further and further down, the numbers are going to get more and more granular. However, it's obvious that we still probably want to report on actuals and forecasts generated by sales reps as well as by these other attributes, and that's a perfect job for a filter file. Here in Forecast Pro, I have open a standard auto parts project. The hierarchy is 5 levels deep. Actually, you can see that down here on the bottom ribbon. And this one happens to go from grand total to region, North America, EMEA, APAC, and Latin America. And then within those, we have product category, air filters, brake pads, fuel injectors, and suspension kits. And then we have, under each of those product categories, we have SKU, followed by customer at my item level. If we wanted to bring sales rep into this project, we do it through the filter section of the data manager. That's on the home tab right here. And filters will be through this path. Let's look at an example of a filter file. This is going to be something that's very easy to create. In fact, all we need as a starting point is a copy of the hierarchy from our historic data file. So here's the hierarchy we just looked at right here. Since we know that the item level or most granular level of my 5-level hierarchy was customer, every column after that is going to act as a filter column. And as you can see, I have a filter column for sales rep right here. So we have Logan, Abby, Brad, etc., our sales reps. And notice in this case, our sales reps are tied one-to-one with our customer base. But it doesn't have to be like that. So if Logan was the sales rep for both PCA and Nexus, we could fill out this filter column however we want. I want to call your attention to the next column too, labeled Distribution Center. This is also a filter column, and notice it's not filled out all the way, and that's fine. In fact, if you look closely, if we scroll through this, you'll see that we just have values for our North America SKU customer combinations. And if we drop down in here, we can see these are all North America distribution centers: Chicago, North, South, Dallas, and New York. Now, the idea I had with this is kind of, I'm running an American business and I want to do additional reporting on my US-based distribution centers. Well, this is less critical for the other regions. And we're in luck here because I'm not required to fill out a filter column all the way. I can have partial filters that only cover some segments of my hierarchy. And we'll see how that works when we load this file back into Forecast Pro Track. So here we are back in Forecast Pro, and I'm going to go to Filters, and I'm going to go to Excel. And here I chose the file we just made. And we'll press refresh, and it will bring it into the project. Now, let me show you how we can use these filters. The first thing we can do is make sure they display when we have the graph or various other reports open. So for instance, I can right-click on the graph, go to Settings, go to Components, and there's a drop-down for Select Filter Attributes to display. So if I wanted Sales Rep to show for each of these customers, I could do that. I could choose any of my filters. I'll just do Sales Rep in this case for now. And we'll hit OK, and we'll see this item, this customer right here is a Matt item, whereas this one is a Logan item, and that is kind of true as we go SKU by SKU. The SKUs won't have them, keep in mind, because we built in the filter at the customer level. But as we drill into the customers, we see those sales reps appear. Those filters will actually also appear in the header of the forecast report if you open that up, and that would be right in this section. But most importantly, we're going to leverage filters on the major reports that Forecast Pro offers. So for instance, if I go and open up my numeric output report and show that right here, and we'll expand it all the way because we want to be able to see everything, I can go into the settings right here. There is this section for additional attributes to display, and whenever I load a filter file, they'll be available. So let's include both the salesperson and the distribution center. And we'll see this makes sense. For instance, distribution center applies to my North America customers. If I were to scroll further down outside of North America into EMEA and APAC, that one wasn't filled out, and again, that's okay because that was a partial filter. On the other hand, sales reps who work with customers individually are filled out for all regions. So we can think about how we would use this report. We could filter down on a sales rep. We could choose Abby, for instance, and this would be a list of every customer SKU combination that Abby is tagged on, and we would have the forecasts for those items, and we could immediately take this and decide to save it to Excel, for instance, for further analysis. And don't worry, we'll do a lot more with reporting in a future example. But what about filters that don't naturally attach all the way down at the most granular level? We can build those too. If I wanted to build a filter that applied up at the SKU independently of what customer is associated to it, so something that takes into account just one SKU independently of what is underneath, we can do that too. So here's a file that will do just that. We just need to set things up a tiny bit differently. We still start with a copy of our original hierarchy, so mine has these 5 columns. But since we're going to build this filter up at the SKU level, the second from the bottom column, we are actually utilizing the customer column, so I'm going to fill that one out with the word null so that we know these filter types apply up at the SKU level. And unsurprisingly, if I were building a filter that applied at the category level, I would stop at category and then say null, null. If I were building one that applied at the region level, we'd say null, null, and null. Now, you can't see it here, but when I created this file, I did deduplicate it in Excel because first, previously, each of my SKUs was repeated in multiple rows because there were many customers beneath each one that were sold into, but I don't need that here. After that, though, it's going to be the same as before. My columns to the right of the hierarchy are my filters. And here I have just one, and it's for product type. So since we're doing car parts, we can look at, for instance, ceramic versus metallic brake pads. These are attributes that I don't want to complexify my hierarchy with. I'm selling the SKU and I'm selling it to the customer. I'm not forecasting individual features. That's not to say that no one is, but for me, it's better to have these mapped separately because my business driver is the SKU customer category combination. That's where I'm building my models. Back in Forecast Pro, we're going to add that filter to the selection. So I'll go here and choose Excel again. And this was our group level filter. We see it stacks here, so I can really have as many filter files as I want. And we'll refresh. And immediately that new group level filter becomes available in the settings of my reports. So I'll go to settings, and we see now the product type or format is available in my selection, and I can choose it there. And you'll see, just as expected, it applies up at the SKU level. So for instance, now I could build a report that isolates a certain type of SKU and breaks it out by product type. So we could choose one of those high efficiency air filter types and see all the SKUs that it applies to. So for our next example, we're going to look at what it means to forecast either top down or bottom up. And in short, this means that the level that we choose to build our statistical model at has consequences for what forecast we end up with. Now, it's important to note that in Forecast Pro, the default is the bottom-up approach, which means that when we load historic data into our project, while models are built at every level simultaneously, the final forecast we get by default starts by taking the forecasts at the most granular level, rolling those up to the group, and then the group of groups, and higher until we reach a grand total. But we have some choices. It's possible to reconcile the other way, and sometimes it's critical to get a good forecast that we understand which level we're building our baseline statistical model at. I have an example right here of a project that contains cold and flu products. Now, I'll say a couple things about this. If you're looking at the numbers, these are going to be in normalized palettes. And if you look at the date range, you'll see it runs from, well, the forecastable period is running through 2015 and 2016. The history kind of goes back into 2012. And because of the date range, there's no elephant in the room. There's no major disruptions from COVID or anything like that. This data is from well before that time. Now, if we go through here, we see we have cough syrup, inhalers, lozenges, night liquids, and pills. And there are some different volumes, but in general, these are the types of products that people are going to have demand for seasonally in the colder part of the year. So we see that in pills, for instance, and we see that our forecast reflects that. But if I go up to cough syrup, this is actually going to be different. Now, cough syrup, I'll break things down. We have underneath the cough syrup category, we have two formats. We have a red cherry flavor, and then we have the regular green flavor. And if I split those down, we get individual skews. So skew is on the bottom in this hierarchy. But if I call your attention to the top level, you're going to see something strange. In the history, we have a very clear double spiked pattern in cough syrup. And the first of each of these spikes is in September. That's kind of all the kids go back to school and it's a big germ factory. And then demand for cough syrup goes up. And then we have our second spike in the colder part of winter, in December in this case. And that is a clear pattern that's repeated across the history here and is going to be similar if I go down into one of the sub-levels. For instance, the flavor, we see that again. But these forecasts are not really good. We have a completely flat line here, almost flat line there, and that amounts to an almost flat line up at the cough syrup level. And this is an artifact of how I described the default reconciliation of forecasts being a bottom-up approach. This is not a forecast that we could really run with because we know it doesn't reflect anything about the historic demand for cough syrup, and if common sense prevails, we're going to expect that double spike pattern in the subsequent year as well. But what's at issue is that you'll notice that about half of my skews, whether it's in the cherry flavor or in the regular flavor, are grayed out. And this means that these items are discontinued. And then the skews that are actually live are very new. So it's as if we discontinued a bunch of cough syrup skews and relaunched them with a bunch of replacement skews that are less than say half a year old, including this one, which only has 2 data points. And what actually happened here is there was a change to how the cough syrup bottle was sold. They put a new sticker on it. They changed how the cap affixes. And that generated new skews in the system for everything. And these items that are actually live don't have a lot of data. And if they don't have a lot of data, they're going to get a very simple flat forecast. So with the default bottom-up reconciliation, a bunch of flat forecasts are going to sum up to a flat forecast at the group. Combined with these ones here, giving us an almost flat forecast up at the top. Another way to think about it is, where is the business being driven from? When we choose where we want to build the model, we want to think what is actually driving the demand. So when people go into a pharmacy looking for cough syrup, they're probably not looking for individual SKUs. And arguably, they may not be looking for flavor either. I mean, if you feel really crummy or someone in your family does, you might just want to go in there and buy some cough syrup and go home. The business driver for cough syrup is the fact that it's cough syrup. Now, this is going to lead us to think about building our model top down from the cough syrup group level rather than any of the lower levels. But we couldn't go anywhere above cough syrup. Well, there is only one level above cough syrup, and that's the grand total. But that would rope in things like the pills and the inhalers, and it would be impossible if I needed cough syrup and they were out of that and all they had left was inhalers. I'd be really out of luck. So we're going to change how we build this model to attach to a higher level of the hierarchy, the cough syrup level, not the flavor level, not the SKU level. And to do that, I select this node, and we're essentially going to say we want to take this aggregate summative history of all our cough syrup data, which, by the way, includes the histories of the discontinued nodes, because they are still in the project, so they are still contributing volume up to the group level. They're just not building forecasts on their own. But when we work from the group level, we get that combined summative history. And watch what happens with the forecast when I choose top down here. Now we're building the model across this group history. And the data is robust enough for our statistical model to pick up that double spike pattern, which is really, really good. Even better, because we've chosen to build the model at a different level of the hierarchy, it will disaggregate down. That's what the top-down modifier that we attached here does. So for instance, if I go into the regular green flavored syrup, instead of a flatline forecast there, we've disaggregated proportionally based on the volumes, that same model. And if we go into the few SKUs here that are live, even though they had very short histories of their own, they are getting a disaggregation of that model as well. So they are no longer going to be flat as we click through each of these, including this one that only had the 2 data points, super low volume. It's even getting shades of that clear double spike pattern because we're inheriting it from the group level. So this is a really powerful tool, and I want to point out that we can choose to be top down or bottom up or somewhere in the middle on a case by case basis. So whereas I needed to do a top down model on the cough syrup level, I had not needed to do it on the pills level. My pills group forecast is stable, is reflecting the history. This is something I can go forward with. So this ties into thinking about how you want to set up your hierarchy to be able to build all the statistical models you want. But also, I would go so far as to say that understanding top-down versus bottom-up and how it applies to your project is one of the key initial steps that every forecaster needs to go through in order to get their project right for their first forecasting cycle. It's a very valuable exercise to think about for all of your items. So for our third example, we're going to look at how entering overrides at different hierarchy levels affects the forecast, keeping in mind that overrides can be entered at any level of the hierarchy, and the math is going to reconcile both upwards and downwards. So this will be a brief example, but key to your forecasting process. So here we are back in Forecast Pro looking at the project we looked at before, the auto parts project. I have one of my SKUs highlighted here, and even though that's at a group level, I'm going to make an override for April of next year, and we're going to put in an override for a one-time special order of 1,000 units into the first override row. I'll make sure to add my comment. And we'll commit the override. Of course, this results in a large spike in the forecast. And to show you the contrast there, I am going to turn on the statistical forecast in the graph settings. So we'll turn that on, and we can see originally the statistical forecast was this purple line here, but with the override added, the adjusted or final forecast is peeking out from behind. We know logically that 1,000 units has to roll up to the category that the SKU is in, and then the geography, and then the grand total, determined by the fact that we went from an original forecast of 104 to a final forecast of 1,000. So really we added 896 units, quick mental math, and that's what we see at the air filters level, you can check, and at the region level, and of course at the grand total level. But the other thing you should know is that overrides made at a group specifically, and this is why we picked this SKU group, also disaggregate to the child items. So in this case, our child items are our customers. So if I go down into Cargo Masters, for instance, one of the customers that buys this SKU, we see quite clearly that it inherited a share of that override as well, as exhibited by this big positive spike, and the forecast adjusting from 71 to 689. That is coming from the extra 896 units we added to this SKU. Another question that sometimes comes up is, why don't we see what share of this 1,000 units goes to each of these child nodes? Why don't we see a number in here? Why do we just see the before and after? And the answer is relatively simple once you think about it. It's because we may want to do our own adjustments in the child items on their own for separate reasons. Yes, we might be promoting this SKU, but also It could be that this one customer is ordering an extra 30 units per month. So we'll do increment 30 for those 3 months. We add 30 to each of these, very simple math this time, and we put that comment in. And we get an adjusted forecast just for this customer, and we see that the node turned red. Now what's going to happen there? Two things. One, of course, all these February, March, and May are going to roll up into the SKU level. These numbers are now different. But also, because we made an adjustment to April, we fixed a value for April. We said they are going to buy 30 units on top of the statistical forecast, ignoring the math that was used to disaggregate this April one-time special order for the SKU and how it was pushed down. So when we fix a number within one of the SKUs, again, the math has to work out, so we might see variations in the other items. For an extreme example of this, keeping in mind that the 1,000 units at the SKU level is our ceiling, if I went into Cargo Masters and put in the same April period a very large special order, something like 900 units, watch what's going to happen. When I go into the other items, we're actually seeing negative forecasts relative to the other periods. We're seeing an adjusted forecast below the purple statistical line, and here we went down from 51 to 45, and here we went down from 14 to 12, and so on and so forth. And why is this? Because our ceiling was the 1,000 units, and we used up 900 of it in this one item. On the other hand, Forecast Pro will prevent you from doing anything illogical on its face. So what I could not do is make this special order 1,001 units. Why? Because it's a child level node, and 1,001 units is higher than the 1,000 units in its parent. And having the sum of the children or one individual child be higher than the parent node is impossible. So we will get an error there. So when you're working in Forecast Pro, making your overrides and adjustments, you have the freedom to make them at any level of the hierarchy. Overrides that you make at lower levels will roll up to the top. Overrides that you make at groups will disaggregate, and they'll do so proportionally. Finally, for our last example, we're going to look at how to use reports and output that get at the data that needs to be consumed once we're done with our forecasting cycle. Let's go back to the same project we were just in. Suppose that we wanted to do an exercise to build a report to check our error metrics for a certain item format. I'll go here to Reports and then choose the Waterfall report, which will show us error statistics like MAD and MAPE getting back into prior forecasts. If you want to learn about how MAD and MAPE are calculated, we have many other videos on this topic on our YouTube channel, including other webinars in this series. Notice that on this report, I've included the product type filter. This is a group level filter that we brought in before. And when I allow myself to sort these columns, I can choose to look at a specific level. For instance, if we want to look at SKUs only, this is how I do it. I'd go into the column for SKU, and I'd say I want to look at everything that is not null. That is, we are looking at SKUs. But if I only want to look at the SKU group without walking down into the associated customers, I can go into the customer column and select only the nulls. So this will be only the SKU group levels, not splitting into the customer. So this is a group level, this is another group level, SKU by SKU by SKU. Furthermore, I could decide that I only want to look at brake pads, maybe SKUs within the brake pad category. And because we have our product type filter, I could decide I only want to look at ceramic brake pads, and I could choose that from the filter, keeping in mind that this is something I brought in externally. It is not part of my hierarchy. So now we are looking at SKUs not breaking it down to customer, and these SKUs are ceramic brake pads as evidenced by our selection. And this is a nice, neat, and tidy report. And if we go over here, we see just the MADs and MAPEs for these items over the last 6 forecasts. The reason I bring that up is because MAD and MAPE are averages, and we can even pretty this up a little bit by going to our MAPE column. So I'll sort these largest to smallest, and we'll throw on some color coding. And when I do that, I'm left with a cohort of items with MAPEs, say above 100% on the top, and we get better and better all the way down to one with a very low error statistic. And we can start analyzing these and thinking about which SKUs we need to keep a lookout for. So this is just one example of a way to easily filter a report down to what we need. I'll close this report and I'm going to open the numeric output and do a similar example. So as we saw before, numeric output is typically used to export all your raw forecast data. We're going to make some changes to this one. We're going to decide that we want to look at region only. So I'll back up here. And again, I'll do this exercise where we choose the region not to be null because we want to see that value populated. But then downstream from that, we don't care what category or SKU we're in specifically. We just want to look at the groups. So we'll ensure that everything downstream from region is null. So here we just have our 4 regions: North America, EMEA, APAC, and LATAM. We also have these filter columns, which we may not actually use. So we could go and remove those if we're not using filters in this context, because we didn't have filters that migrated up to the region level, although we could have them if we wanted to. And I'll make another change in the settings. Rather than looking at our point forecasts, which are our final adjusted forecasts that include overrides, of which we made some in this project, I'll go into settings and I'll go into time series data, the second tab, and I'll switch our output from forecasts to statistical forecasts. Another thing I'll do is add some totaling in the layout. So I'll go to tab number 1, layout, and include both row and column totals. And when I hit OK, you can see here we have our geographic groups. We have their statistical, not final forecasts. And we have a total row at the bottom collecting everything. Likewise, we have totals for each of the individual rows all the way to the right. And probably I want to save these settings and not have to reapply them again. So this is a good place to add a layout. And we'll say this is regional stat forecasts. The fact that I saved that regional stat forecast layout allows me to snap back exactly to where I was, 4 rows, 1 for each region, without committing all the click actions again. So, and that takes us to the end of our examples. So to summarize what we covered today, your project's hierarchy is a primary key for your data. You can have as many levels as you need, and they can be ordered however you want. And naturally, there will be attributes of your data that don't belong in the hierarchy, and that's fine. We'll build them into filters. The structure of your hierarchy is going to have ramifications for how statistical models attach to the data and how adjustments and overrides roll up and down. Finally, structuring your reporting is key. Bringing together hierarchy levels, filters, saving your reports as layouts allows your reporting and data output to be repeatable every forecasting cycle. And just as for this webinar, again, as we mentioned in the introduction, we'll be running these once a quarter. The next session will be in February, and it will cover collaboration and overrides. My colleague James will be the speaker on that one, and we'll put a link to register for that session in the chat right now. Just as a reminder, you can review all our previous events and webinars either on our website or via our YouTube channel. Finally, we're going to move on to our question and answer section of the webinar. So if you have not done so, please use the chat to enter any questions that you have. We're going to be answering them now. So thank you very much once again for attending, and let's get on to your questions.